Welcome, ladies and gentlemen. Happy Monday morning. Raise your hand at this time if you did not get a red mark for today, the 26th. 26th? Okay, let's go ahead and get going. So several things that we ran into on the test include graphs of linear equations, right? Graphs of linear equations, whether they're a special line, as these two Bellwork questions are, or if they're a slanted line. And so let's go ahead and take a look at the first one. I remember that the graph of a linear equation x equals 5 connects all the points that share the same x coordinate, and whose x coordinate is 5. And so if I'm thinking of different points that might be on this line, I think of 5, 0, 5, 1, 5, negative 3. Give me a different point. Cody? 5, negative 2. And so if I were to, if I were to attempt to talk and write at the same time, then we could run into some dangerous situations. Okay, so if I were to graph all those together, what would it look like? 5, 0, 5, 1, 5, negative 3, 5, negative 2. We'd have a vertical line, And raise your hand if you have that picture in blue. So who are that? Vertical line, and keep your hand up if you know the slope. So what's the slope of any vertical line? Thanks, hands down. Mark? Undefined. The slope of a vertical line is undefined. Its equation isn't undefined. Its equation is x equals 5. Connects all the points that share the same x coordinate, and that x coordinate is 5. But its slope is undefined, right? We can't measure how much a vertical line rises or falls as you move along it from left to right, because you can't move along a vertical line from left to right. Y equals negative 3. That has points on it like 0, negative 3, 4, negative 3, negative 2, negative 3. If I were to plot all these, what would that look like? So here's 0, negative 3, here's 4, negative 3, here's negative 2, negative 3. And so the collection of all those points would be a horizontal line. And what's the slope of a horizontal line? Logan? 0. 0, so the slope of a horizontal line is 0. And raise your hand if you have that for the second one. So horizontal line and the slope is 0. Great, thanks, hands down, nice job. As a setup for our discussion today, right, bless you, keep in mind that exponents, right, exponents represent repeated multiplication. And so if I'm taking a given value, and squaring it, it means multiplying by itself twice. Be careful with your use of parentheses here, or lack thereof, right? If you put negative 2 squared in your calculator, if you don't use parentheses, it will give you the incorrect value, right? If you just put negative 2 squared in your calculator, that will give you negative 4. Is that what a squared is when a equals negative 2? No, we've learned that any quantity squared represents a positive value, right? So when I have any real quantity like negative 2 and I square it, multiply by itself, the result will be a positive number. So let's try. Negative 2 quantity squared would be negative 2 times negative 2. That's a positive. That's a positive form. Negative 3 squared would be negative 3 times negative 3. That's also a positive. And so here we're not getting negative 4 minus 9 is negative 13. Oh no, this is a positive 4 plus a positive 9. We should be getting positive 13. Raise your hand if you got a positive 13 for that. Positive 13, good. So this is an instance where you might not want to use your calculator, or if you do, all right, use parentheses like I've explicitly shown. I always use parentheses in that first evaluation step, and that way I don't mess up order of operations, right, or PEMDAS. A cubed minus b. Oh, let's try it. So a cubed minus, oh look, I'm using parentheses for all of my substitutions. So a would be negative 2 minus b, b is a negative 3. This way, by writing in parentheses before I do my substitutions, I'm going to follow the order of operations correctly and get the right result. So negative 2 cubed is not 6. It's not negative 6. It means negative 2 multiplied by itself 3 times the number of exponent times it tells me to. So here we go. Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. So negative 2 cubed is negative 8. And then minus a negative is the same as plus a positive, because subtraction is just adding the opposite. So here we go, negative 8 plus 3, I'm getting negative 5. Raise your hand if you also got negative 5. Negative 5, Hey, that's great news. That bodes well for our activity today. And lastly, b minus a all over ab. Oh, goodness. There's a whole slew of evaluations here. I'm going to do parentheses, minus, parentheses, all over, parentheses, times, parentheses. And let's see how it goes. So b is -3. Minus a is minus a -2. All over ab is -2 times -3. Let's try it. So here we go. -3 minus a -2 is -3 plus 2 is -1. All over negative times a negative is a positive, so I get -1/6. And raise your hand if you had -1/6. Anybody else already have that? Yes, you did? Hey, that's great news. Please distribute and simplify. As another setup for today, we can distribute, right, an outside factor through parentheses using multiplication. We just want to keep track of our signs and, in this case, our exponents. You know from Algebra 1 that x times x, right, isn't 2x. X times x is x squared, right? We multiplied x by itself twice, so we use an exponent to show that. Let's go ahead and see what happens when we distribute this outside factor through the parentheses. So we've got -2x times x is -2x squared. Then -2x times a -7 is positive 14x. And lastly, minus 3x squared. So now we'll go ahead and scan the problem, right? We've distributed through successfully, but we have a pair of like terms. So this isn't fully simplified because we have a pair of like terms. I know that I can combine x squared terms with other x squared terms through addition or subtraction, though I cannot combine x squared terms with x terms through addition or subtraction. So we can go ahead and pick out one pair, -2x squared, -3x squared. Those are like terms. We can combine those through addition or subtraction. And so we combine those and get -5x squared plus 14x. And we could write that in either order. We haven't done anything with exponents thus far this year, and so today we'll be able to handle expressions like this with more ease. Go ahead and raise your hand if you got this though. So this was kind of a blast from the past in Algebra 1. So several people did. That's great. So you've combined like terms correctly. That's good news. Okay. What questions do you have about today's Bellwork then? Awesome. Then, before we get going on our activity, we want to make sure we have common vocabulary. So, when we talk about exponents and powers, right? Exponents and powers, we're representing repeated multiplication, right? In a power consists of two pieces. A base, thank you, a base and an exponent. So the whole thing together, like x squared is a power. In this case, the whole thing together, 2 to the 5th, is a power. So the whole thing is a power. The little superscript number right there, we know that's the exponent. And the factor that's multiplied repeatedly, right, is the base. And so power consists of two pieces, the base and the exponent. The exponent tells us how many times that base is multiplied together. So there we go. We see 5 factors of 2 multiplied together in a row. The whole shman is the power. Awesome. We need to know that because we need our vocabulary for our activity, because you'll be running into a whole bunch of powers. That's what I'm talking about, baby. A whole bunch of powers. We're going to work on our exponents and rules of exponents. So we're going to work on this together with our cooperative learning group. We've done several partner practices before, but we're going to do our full group today. Make sure that you're taking turns, right? If you want to designate one person to stay the reader, that's fine, if that's their strength. However, we want to make sure that everybody's getting our properties and understanding as you go through. And everybody has to agree before I'll come and stamp you guys all at one time. We've got, just one sec before you move. We've got 1D, 8, 18, 20D, 23, 28, 33. Guys, 37, 38 is just a single stamp. Okay, that's at the same time, so it's one stamp at 37, 38. 41, and then summary part E. This is out of a whopping 10 activity stamps. So it's a big chunk, all right, of work today and worth a lot of points. I'm gonna leave this up on the whiteboard so you'll see exactly the stamped eligible items, and then save energy by turning the smartboard off, and then we will come back together for closure. Okay? What questions do you have about the the rest of the time, then I'll pause the recording and you can get started in your groups right away. Thank you. Excellent. So let's go ahead and take a look at our first property. If we multiply two powers together that have the same base, there's a shortcut operation we can perform with the exponents. Please write that symbolically with x's, m's, and n's and be ready to share. If you need to glance back in your packet, you may. And it's okay to check with your partner so long as you do so quietly, okay? And number two, if you raise a power to a power, we had a shortcut operation that we could write with the exponent. Go ahead and do that symbolically and write as a single expression without parentheses. The same for 3 and the same for 4, and we're going to go ahead and share responses in about another minute. Okay, get ready to share. I'm going to call on you to share with the whole class now. So how could I write x to the m times x to the n as a single power without parentheses? What would that look like? Cody? X to the m plus n. Raise your hand if you have the same thing. X to the m plus n for the exponent. Way to go. You add exponents and multiply powers with like bases. How could I rewrite number 2? Raise a power to a power. What would that look like symbolically? Margot?
X to the a times the.
Good. X to the ak, where I multiply exponents when I raise a power to a power. Excellent. And x to the g over x to the h. Aaron? Awesome. And who gets raised, the e or the f? Barrett? They both do. Excellent. Thanks, you guys. Have a great day. E to the r. F to the r.
Jessica, Adv, and Ursula.
Good job, you guys. Have a great day.